This is a quick review of the ABB Rolling Roadshow truck. The Rolling Roadshow truck is an all-compatible experience displaying ABB's drive portfolio, automation products, service, and live demonstrations on how ABB solutions can help you improve your processes and solve problems while saving energy every day. ABB drive products and provide solutions for applications supporting generic industry, HVAC, food and beverage, and industrial applications. This is a quick look at the Harmonic mitigation solutions demo within the truck.
Alright, we're going to go through the Harmonic demo that we have here in the truck right now, and we're going to look at the different drives and do a real quick review of what kind of harmonics are created by each type of drive. The first drive we're going to look at is a 6-pulse drive without a reactor. This is basically a component level drive, and this is an ACS 180 right here. And it doesn't matter if it's an ACS or ACH. Those drives are basically the same hardware, they're the same harmonics. In this case here, we're running 2 motors, 20 horsepower apiece. One is across the line, the other one is being used for a load motor, for all the rest of us. And right here, we're looking at the input current coming into the drive. This input current is showing about 65 to 70% total harmonic distortion at the input of the drive. And we have these double humps, and these double humps are the surges of current being drawn in through the full wave bridge. If you look right here, you see that we have the diodes being represented here, and a cap bank, and then we go to the outputs of the motor. All we're going to talk about for harmonics now is just the front end of the drive. And that's from the cap bank through the diodes and the front end of the drive. If we look at the harmonic schedule here, we see the 5th, the 7th, 11th, and 13th harmonic, and compared to the fundamental, the 5th is showing 55, almost 59% of the fundamental current of 60 hertz, and the 5th is 300 hertz. And each one of these frequencies is a multiplier of 60 hertz. So that's the equipment that's set up. Now we have the ability. We can go ahead and change. We're going to change over to the 6-pulse drive with a built-in DC link choke. This would be the drive that you would buy most of the time. The drive itself has a dial bridge and a DC link choke in place. If anybody talks about a DC link choke or an AC line reactor, they both do the same thing. And there's a cap bank. Now that DC link choke opposes the change in current. And if we look at our current patterns right now, you'll see that instead of having those heavy rabbit ears, we have a double hump right now at each one of the phases. And our total harmonic distortion has dropped down to about 30%. And if we look at this chart here, and on the video it might look the same, you have to see though, is now a percentage of the fundamental is 25% right here. So our 5th, our 7th, our 13th, and everything else have all dropped tremendously. And that's very common with a dial bridge, with a built-in DC link choke. Now, a lot of people will say, I need to make 5% total harmonic distortion at the terminals of the drive, which isn't really an IEEE 519, but people do that all the time. So they'll buy a 6-pulse drive, and they'll add, down here, a harmonic filter. And inside this cabinet, the cap bank and the 2 reactors, all of that creates a harmonic filter to filter out the harmonics in front of the drive. So I will turn that on right now. I have a harmonic filter. The harmonic filter is now in front of the drive. It's all stabilizing right now. What's happening is now my total harmonic distortion, and if you see we don't have any rabbit ears at all anymore, my total harmonic distortion is showing 5.9% to 7.3%. That's only because we're hooked up to a generator right now. Filters and generators, things happen with that. If we were hooked up to the building right now, building power, this would probably be 5% or less on each phase. And here, now 5% is right there, where 25% was before. And we still got the 5th, 7th, 11th, 17th, but they're all very low. So this, you have to remember, you would have to buy all this equipment, buy the drive, and then if you bought it separately, you'd have to mount the drive, then you mount the equipment, and you have to wire between the 2 points. Our solution nowadays to this is the ULH Ultra Low Harmonic drive. This is an active front end drive. The ACH 580 ULH drive has it all built into it. It's designed for low harmonics. In this case here though, just because I'll just point out one minor thing here, this drive itself will go up to 60 horsepower. It's a 20 horsepower drive in this cabinet, but its hardware would go up to 60 horsepower. So when you look at the size of this compared to the size of this 20 horsepower drive, this is just because of our cabinet here. So this package here does everything that this package, this drive, and this filter would do, but it does it better. Our total harmonic distortion is evening out around 3% or less right now on the generator. Because we have a nice sine wave for our current coming in, other things we have is we have unity power factor now, which means the generator would only need to be sized for the load only. You wouldn't have to worry about inductive loads or capacitive loads or anything with our drive. This has a unity power factor, so you don't have to oversize your equipment. We're at 3% less total harmonic distortion. This chart here, we are seeing a little bit of third here. See the fifth, the seventh, so forth. The 3% is right here, and these spikes that are moving up and down in percentages, we're averaging out just about 3.4. The whole chart we scaled there. So what we have here is an ultra low harmonic drive. Other things you can do with ultra low harmonic drive is you can set them for leading or lagging power factor to correct power factor in your facility. There's another paper coming out that soon. I'm actually having a presentation today on that. The last thing we'll point out is that if you want to go old school, we have what we call 18 pulse drive. And if you look inside this cabinet, down there is the auto transformer. I'm good there.
All the way down there?
That big transformer, you need that to separate your 6 pulses to go up to 18 pulses. So your 3 phases have to be separated into 9 phases. And you need the extra inverters, the chokes. Here's a 20 horsepower drive. You actually use the front of the drive. All this hardware is needed to do 18 pulse. And I can actually go to an 18 pulse drive. 18 pulse drives are much more common in wastewater in the old days, but nowadays with the newer technology, it's been much more well accepted. Going to ULH drives is much more efficient. So looking at size wise, here we're at 18 pulse right now, but because it's on a generator, I'm seeing almost 15%, 14% total harmonic distortion. If we had a stiff enough line, this would drop down to about 5%. But once again, we see this distortion on generators, which affects your generators as a whole. And you get your harmonics here, 12% is about right there. Here's your new harmonic profile that's showing up. But remember, if you looked at your 3 different solutions you can have, one would be to get yourself to 5% or lower total harmonic distortion. One is to buy a 6 pulse drive, buy a filter, and do all your energy into the filter and burn up the heat. The other solution, get an 18 pulse drive, which is even much bigger and heavier and more expensive. Or go with the modern day ultra low harmonic solution. Which the ULH drive will solve that, and we have much more options. You're also going to deal with a lot more line imbalance and other things where ULH adapts to it, where the other drives will start you in with the high harmonics.
Thanks, Tom.
Thank you.
The Rolling Roadshow contains many other options and many other displays that you can interact with and learn about ABB products. If you're interested on how an ACH 580 ultra low harmonic drive really does work, check out this video on demystifying ultra low harmonic drive operation. This video will explain how an ultra low harmonic drive produces low harmonics on input, how the drive can boost its input voltage, supporting higher voltage on the motor even with lower line conditions, and how the drive actually does work. If somebody says things like they act like noise canceling headphones, they're wrong. Check out this video. This will explain a lot of information. It's designed to be easily gone through using very low level math and easy to understand. Introduction to Power Factor. This is an online webinar for easy to understand what is power factor, how it affects your building, and what kind of solutions you can use to resolve power factor issues. The ABB ACH 580 Ultra Harmonic Drive has the ability to correct displacement power factor, and this is an introduction to that ability.